All right, so it's recording now. So this is just meant to be a quick primer on LLMs and RAG and vector database. So LLM, as we know, it's just like you can think of it like a black box right now. We don't know, and like it's not important for us to know at this stage what it does internally and like how it works. But this is how roughly the flow is with LLM. We ask it a question, which is the query, and it gives us an answer. Like what color is the sky, and the sky is blue. This is what if you go to ChatGPT, if you ask this will be the response. So this is what we call input tokens, and this is the output tokens. Okay.
Yeah.
Okay. And so token is, I think, nothing but another word for like words. So they have their own way of counting tokens, and token is just something that like a terminology that they use internally. And roughly, I believe, 4 words or 4 tokens is 3, something like that. Like if you ever want to count the number of tokens, so this is like in tokens output or input output. And if you ever want to count it, you can just go to open browser and see. So this says it has 5 tokens, and these are the 5 different tokens and 21 characters. Okay.
Okay.
So these are the input tokens, output tokens, and this is roughly like 5, 6 tokens. This is another 4, 5 tokens. Okay, or three words. And when OpenAI builds us or OpenAI detects usage, what they do is they just have a pricing on tokens. So we'll just go to the pricing page. Yeah. So right now you can see price per million tokens. Million is 10 lakhs. So $2 per 10 lakh input tokens, and to $8 per 10 lakh output tokens. Okay.
Mhm.
So LLMs have this thing. So the reason why we're understanding what input and output tokens are. So if we combine this input plus output, that is the total tokens being used. Okay. Every LLM has its own context limit. Have you heard of this term before?
Yeah, I heard it.
So when we started working on this, the context limit used to be 4K tokens. Now I think there are much bigger models. I think some models have 100K, and biggest ones I believe also have 1 million tokens as the context limit. So context limit is nothing but what is the longest a conversation can be. On ChatGPT, we have many conversations with it, right? And the conversation gets bigger, reach a point where, so if you copy all this text and put this in tokenizer, that's the total number of tokens being used, input plus output. Okay.
Yep.
So at some point we hit what we call the context limit, and which is like 100K tokens, or like as the models have gotten bigger, it's becoming easier. But when the context limit was much smaller, what happened was if you were to put a big PDF containing 100 pages, let's say you put in all the Harry Potter books together on the LLM on ChatGPT, and then start asking questions about Harry Potter. What it used to happen is it used to just say context limit is full. Please start a new chat. Something like this. Have you experienced this?
Yeah, I have a lot of times.
Yeah. So this is our context limit. So how we solve this is with the help of a vector database. So this is just a new way of doing it. The explanation that I'm going to give you is it's going to be very simplified. Like there's a lot more that happens, but I'll just tell you what's like important for us to understand right now. So this is our LLM. What we do is what we give it an additional superpower or an additional resource, which is the vector database. Okay. Now vector data. So now if I ask, Now what we do is whenever we want to give it some data or some like information and which is very big, which is like much bigger than the context limit, what we do is we convert it into a machine understandable language, which is vectors using embeddings, and we just store it in the vector database. So if I were to talk about the same Harry Potter example, what we'll do is we have 8, 10 books. So we'll just do 1.pdf, 2.pdf, whatever those books are. We'll ingest them into the vector database. We'll do some processing. We'll convert them into vectors, and we'll store the vectors of all the all the Harry Potter books. Okay,
Mhm.
and then this we are not putting this in the LLM context window just yet. We're just putting it on the vector database. And then we connect this to that LLM.
Right.
Okay. And then now if I ask what I don't know color is the sorcerer's stone. I don't know. This is just an example of a question from Harry Potter. Now what the LLM will do is LLM will try to understand what is this question, like what kind of question this is, and where exactly can it find the answer to this question. So it will convert this as well into a vector understandable form, like into a vector through the same embeddings, and then send it to the vector database. Okay. A vector data, now we do something called similarity search there. So what it will do is it will pick up all the words and all the context from here, and it will look for the 5, 10 vectors which have the
Right.
information that we're looking for, right?
Yep.
So, for example, we convert, first of all, what we do is we convert this into a vector. So in vector, this will look something like this, in ones and zeros and numbers that represent the semantic or the meaning of this, okay?
Mhm.
In numbers form, the meaning of the sentence.
Correct.
Now this is now sent to the vector database, which already has like tens of these or hundreds of these vectors. And when we ingest this on the vector database, we break it down into chunks. So you can count, for example, a good way to break it down is page by page. So page one is one vector, page two is another vector, page three is another vector, page four is another vector, something like this. And what similarity search will do is it will pick up the pages which contain the question information that's most related to this. Okay.
Mhm.
And this vector database will decide, okay, these two vectors may have, or these two pages may have the answer that we are looking for. Okay. And then these three combined, the vectors coming from the vector database, and this is finally what is sent to the LLM. Okay. So in short, what we are doing is instead of sending hundreds and thousands of pages to LLM and blocking all context window, we are just sending the ones which are related to us with the help of a vector database, and then asking it the same question, and then it is able to answer. The philosopher's or the sorcerer's stone is red or crystal red or whatever. Are you getting?
Yep.
So this is what we do.
Just a question I have actually.
Mhm.
We are actually connecting DB to the LLM, or we are feeding the whole data to the LLM?
We're not okay. So we're not really directly connecting this. There is an like, intermediary step in between, which can be a Lambda function or which can be a server, which actually does this.
Okay.
What we are doing is before we when a question is asked in the LLM setup, this is not directly sent to the LLM. This is first sent to the vector database.
Okay.
Then vector database figures out, or if you're using OpenAI tool calls, okay, I don't want to confuse you right now, but what we're doing is we're sending this query to the vector database first, or even before that, we're first converting this into a, like with the help of embeddings, we're converting this into a vector. Now that vector is being sent to the vector database. There we do something called similarity search, which is just the vector is giving us the vectors which are, we can decide on how many vectors we want, but the vectors which are, the most similar to the one that we sent in the query. And it will give us maybe 5, maybe 10 vectors. And then, so this is what we call context. So this was our query. This is our query. This is the context.
Okay.
This is both combined and then finally sent to the LLM. So we're not just sending our question, we're also sending the answer or the potentially the answer from the vector database where we can find the answer. Like if I ask a question and I know in my textbook it is on page number 25 and 27. I'll only send page number 25 and 27 and not the entire textbook
Okay.
to the LLM. And then it should be able to answer.
Okay. Got it.
So this setup is called RAG, Retrieval Augmented something. I don't remember the full form.
Mhm.
And this system is just solving the problem of any guesses? What are we solving here for?
Context.
Yeah, context limits. Exactly right. Okay. So this is already implemented in our product. One second, I'll stop the recording.